Hi folks, welcome to episode 0.1 of the Plaid++ project, I guess we'll call it. This one is actually just a bit of a show and tell. So I'm calling it 0.1 because I'm going to cover a little bit of the background, a little bit of the technical stuff, but it's not quite into the how-to section yet. So this is still worth watching to understand kind of how we got here. And one thing I just want to say up front is that I know folks have opinions about the yoke versus the wheel and all of that, but I want to avoid these videos being about that discussion, okay? I'm just excited to show you what's possible with a bit of reverse engineering and programming. And at the end of the day, use whatever you like and feel free to do whatever you want with your own car. Yeah. Now with that out of the way, let's take a look at this stupid yoke. So what we have here is the yoke minus the airbag. Mine wasn't recalled, so it's just not installed right now. And this side here, this connector here is for the airbag, and then this one is for the yoke itself, for the controls on the surface. And so let me flip this up here, and normally this is what it is sitting on top of in the car. So this is called the SCCM, the steering column control module. And this is this SCCM from a Plaid. And so what we'll do here is we'll flip this forward and we'll pop this connector out. I've already undone the clip, so it's not normally that easy to take out. But so we separate these, and if you pull the yoke out of the car, then what you'll be left with is a steering column with this in front of you. And I want to show you sort of the background on where I got this idea, or not the idea, I guess where I started. So if you've never checked out epc.tesla, it's pretty cool. It's their parts catalog. And I was looking at EPC. I already knew that I wanted to do stalks, right? I wanted to add turn stalks because I didn't care for the haptics. And I went into EPC and I thought, you know, we had actually taken apart some of the car already and knew that it was very Model 3 underneath the covers. And so I kind of wondered, you know, have they moved over some of the parts like this and made them, brought them in line with the Model 3? So I went to EPC, and so this is the steering column of the Palladium, they call it within EPC, but the Plaid. And this is this part right here. So same one, right? This is that view of that part. And then I went to the page for the Model 3, and I looked at this. And that's the SCCM for the 3. At a glance, it looks like they might be different, but a couple of things stood out to me. One of which was the connectors obviously coming through the wheel look the same, or that go through to the wheel look the same. But also that Coastal or Costal, I don't know how you pronounce it, actually makes both of these. So these are actually made by a third party for Tesla. This company does SCCMs for multiple OEMs. The part numbers were different, but they were similar enough that I was interested. So I immediately rushed down to the nearest Tesla service location, which is where you have to go to get parts. It's kind of hard to order them without going there in person. And I have a Model 3, so I just ordered this with the Model 3 VIN and ended up with something like this. Now, this isn't the one that I bought from Tesla. This is actually one I bought from eBay after the fact to mess with. These are actually much cheaper to get from eBay, so highly recommend going that route. And so let me move this out of the way. So let's take a look at these side by side. So again, this is straight out of a Model 3. This is, you know, just an eBay special. Somebody yanked it out of a car and sold it. And this is the one from the Plaid. And the similarity is striking, right? If you flip these over, you'll see that the back looks the same. And it turns out that the one from the Plaid is actually an identical part number. So it's hard to see here, but like the part number that is embossed into the surface here is actually identical. It is the same part, but there's a major difference. So on the one with the stalks here, it's kind of hard to see here. Let me grab a stalk out of this one. So on the Model 3, you have these stalks installed, right? And actually the method you install them is pretty simple. Like this one actually, this side, the turn signal side just snaps right in. And then you have these ribbon cables that feed down into here. And this is actually a disassembled one. So this is the board that's inside here, right? So that's the ribbon cable. And it's kind of funny, you can see those are the pins that come out of the connector back here that go up the rest of the way to the car. So the very first thing I tried, which I did kind of expect to fail, but the very first thing I tried was, okay, let's take this brand new unused SCCM that goes to a Model 3 that I bought from Tesla, and let's just see what the car says. And the car was obviously not happy about it. It actually refused to go into drive with this one. And the reason is it's got a different firmware version, and so, you know, for safety reasons, whatever, they don't want you to use this one in the car. There's also a less obvious problem that you would have if you just tried to use this. So even if you did something like CAN interception, there's one tricky part, which is the steering angle sensor. So the cars use this for a lot of things, but you can see like there's an arrow here, and that's center point on the steering angle sensor. And the CAN controller in this sends out that steering angle to the car constantly. Well, when I put in the brand new one that had never been in a car, it told me that my steering angle was 378 degrees. So more than 360, probably not ideal. The way you could fix that pretty easily is using Toolbox, Tesla's maintenance software. But you know, that's not something that most folks are going to have access to, and I wanted to do something that anyone could do. And on top of it, like changing that out still meant that you would have to do something with CAN bus, because this thing sends CAN messages that are not expected by the Plaid, even if the angle sensor is correct, right? So it was actually easier to not integrate with this. And one of the misconceptions I've seen people saying, like, oh, did you modify the firmware? I actually didn't modify the firmware. So the one in my Plaid is completely stock. In fact, everything I've done is entirely reversible in the car. And so you'll notice earlier I was demonstrating on this Plaid one what I could do here is just slot this in. And that's fine, but if I plug this ribbon cable in, it just ignores it. So the firmware on the Plaid SCCM, while physically identical, ignores everything down here. It doesn't even try and send the messages regardless of what you do. It doesn't complain, it just doesn't do anything at all. And so what I ended up deciding to do was say, you know, this is actually advantageous, right? Because it dissuaded me from messing with this at all. So just leave the stock SCCM in the Plaid and concentrate on this. And so what I actually did was, it's got these nice test points on it, like these little gold pads here, and each of those gives you a specific resistance, right? So so if I connect a ground in any of these pins and I send a voltage through it, then you know, say I send 3.3 volts through a voltage divider, and we'll go through this in a future episode. But if I send that through one of these, it'll come out as 1.8 volts maybe when it's in the neutral position, or, you know, the resting position here. And then if I do this, it'll actually go through a slightly different set of resistors and give me a different voltage value. So maybe down is 1.3 volts, and then you know, all the way down is 0.9 volts, and up is a higher voltage. And same deal for forward, backward, and this button on the end. And so reading those analog values into something is useful, because then you can turn those into signals that the car understands. So the next step from there was to actually hook up the multimeter and look at what those values were. And again, we'll cover that in the episode about stocks, but I'll just show you a quick demo of where I ended up with that. And this is, by the way, a particle photon with a car loop on it. So this is kind of a really cheap and easy way to mess around with CAN stuff. I will caution you that while you could do a turn signal stock with this, it doesn't have enough inputs and outputs to handle everything for the project I'm doing. So consider this a demo, and if all you care about is adding one turn signal stock, you can actually use this device. So I'll go over that in a future video, but just be aware that that is not the device that I'm using in the car right now. So, so just to show you what's possible here, and by the way, so on the version in my car, I actually soldered to those pads. They're actually quite robust, but you could do this either way, and I might recommend, later on I found these cheap FFCs, flexible flat cable connectors. It's the wrong number of connections, obviously, for this cable, but I just used the ones off to the side and sort of did this and, you know, pop that down. And actually, you'll notice, so on the firmware I wrote for this, which is very basic, it's sitting there at blue right now, but if I just pop this in and push it all the way to the side and then, oops, then lock it down, you'll see it goes to yellow, and that's kind of the neutral light. And one of the other nice things about the particle and why I used it for this project was because it has this handy multicolor LED that you can use for status. And so knowing, you know, I used the multimeter to know what the voltages were. And from that, we can start to determine the position of the stock. So what we'll do, keep an eye on the light on the particle. And so I'll go down one click, and it's going to go blue, right? And then I'll go one click further, and it's going to go brighter blue. Back to neutral is yellow. Then we'll go up, and it's red. All the way up is brighter red. And then pull back on the stock, which is normally just your brights, is bright white. Push forward is a duller white. And then finally, the button on the end here is green and then dark green. So that's just showing that we can read the state of all of the positions of this lever, and this microcontroller can then turn them into something else, right? So, so yeah, that's it for the 0.1 intro to the things involved in this. Oh, sorry, one thing I want to add to this really quickly. So you only need a few parts to do this. Let me move this out of the way. So this is the steering column shroud for a Plaid. A word of warning on these. You'll see that there are 3 clips remaining. These clips on the Model 3 Shroud and the Plaid, every one of these are effectively single-use clips. Like you're very likely to break one. They're not very robust, and so this is what the shroud in the Plaid looks like, and then just compare that to this one from a Model 3, and you'll see, you know, overall structurally they're quite similar. This one actually kind of extends up, so this one makes room for the turn signal levers, and so it kind of slopes here, and it's kind of funny. This one, you know, just they extend this up because that's where it connects to the SCCM. I'll show you that quickly here. So the SCCM kind of sits right here, and there are these 2 screw holes that the shroud attaches to, and so they just kind of kept those arms in place when they did the Plaid. But a lot of good reuse of existing things in this platform, and that's a major plus for Tesla, to simplify the parts bin and do all these things. But the thing that's great for us is it means that this shroud, it's not identical. Like you can see the slope is different down here. That one's got a sharp rake and then goes straight back. This one has more of a curve to it, but they fit perfectly. So there's nothing to modify. And when I was originally considering doing this, I fully expected I was going to be 3D printing something. And the great thing about this project is it doesn't require really much of that at all. So yeah, so that's a quick overview of kind of the background and some of the early pieces, and looking forward to sharing more in future videos. And the actual instructions, the how-to, will start in the 1.1 episode in the near future. So again, thanks for your time, and look forward to chatting with folks about this and seeing what enhancements people make to it. Thank you.